Okay, so in this video, we're going to talk about the last step here, kind of putting it all together, solving a right triangle. And so you see I've taken off the solving for a side, solving for an angle. When we say solve a right triangle, we mean to find everything that is missing on it, all the missing sides, all the missing angles. They are always going to give you technically three things: the right angle, and then either two sides or an angle and a side. They can't just give you all three angles, that wouldn't work. But we are going to be using any methods that we know how to do. So the first method we've actually learned is not even in this chapter, but it is the Pythagorean theorem. That's the a squared plus b squared equals c squared. So that's our first thing we can use. We can also use SOHCAHTOA, regular old right triangle trig, to solve for a side. And then we can also use our inverse trig. So inverse sine, inverse cosine, inverse tangent to solve for an angle. I guess there's probably one thing I should have put in there before also. We can use the triangle sum. So the angles of a triangle have to add up to 180 degrees. That one's going to get used as well. So let's just take a look. We've got two examples here. I'm going to give you one that has two sides and then one that has a side and an angle. And we're going to go ahead and find everything. First thing I'm going to go ahead and do is just put variables in. I'm going to put x, y, z. And we can find really any of these that we want first. In this case, since I have two sides, I might just go ahead and say, well, let's find that last side and use our Pythagorean theorem. So I would know that in this case, x squared plus 8 squared has to equal 22 squared. I will grab my calculator here. And we'll go ahead and just let's see what 22 squared is. 484. So x squared plus 64 equals 484. I'll subtract 64 from both sides. So x squared equals, so 484 minus 64 is 420. And then I need to take the square root of both sides to figure out what x is. And it looks like it would be, if I go to the nearest tenth, 20.5. So I'll go ahead and write that over there, 20.5. So that's our first thing. We found x. Now, one thing I do want to make sure that we are thinking about here, when we go to find these angles, we do not want to use that 20.5. The biggest reason is that that is a rounded value, and it is going to cause all our other answers to be off even more. So if I use that value inside of one of my trig equations to find y or z, it's going to cause y or z to be off by even more. We don't want that. So we're going to try to stick as much as possible to using only the values that they were given to us in the problem, in this case, the 8 and the 22. Now, from here, we can either find y or z, and it's really important that we decide on, well, which one are we actually finding first? Because when we go to do our trig, it matters to naming these sides. So if I would say, let's find z, that means that the 8 is the adjacent side, and the 22 is the hypotenuse. If I was instead trying to find the y, that would make the 8 the opposite side. And so it's really important. And so it's really important that I decide on the angle I'm finding first before I start to worry about which sides they are. So if I'm finding z, I've got the adjacent and hypotenuse. That means I know the cosine. I don't know the angle, but I know the cosine is 8 over 22. And so I'm going to use the inverse cosine. Oops. So I'm going to use the inverse cosine, put my ratio, 8 over 22, in there, and that's going to give me z out as an answer. And so I will type that into my calculator, inverse cosine of 8 over 22. 8 divided by 22. And we get 68.6, so we're going to go with 69 degrees. So that is z. I'm going to round angles just to the nearest whole degree. I'm not too worried about decimal points on my angles at all. Yeah, my pen decided to not connect anymore. One sec. Connect. There, it connected again. Okay, so I'm going to go ahead and write just 69 degrees in here. Now, as far as finding our last angle, this is one place where it's okay to use that 69. If we were going to use the triangle sum to find this last angle, all we're doing is subtracting, and that's not going to make our rounding any worse at all. So if I've got 90, 69, and y, I know that those have to add up to 180. And so I'll just add up the 90 and 69, which would be 159. And then I will subtract that 159 from both sides and get 21. So y has to be 21 degrees. One thing to kind of keep in mind here, don't pick harder methods than you have to. If you've got two of the angles, use your triangle sum to find the last one. You're going to end up with the same answer if you went and go back to and try to use y to find that, but why bother? Okay, the last one here, this one we've got an angle and a side, and so we're going to be able to do some slightly different steps here than the last one. So we'll get started here. I'm just going to put some variables in. We'll call this one x, this one y, and that angle z. Easiest one to find right away is z, because I can just use my triangle sum. Z plus 90 plus 75 is 180. Well, that means z plus 165 is 180. And when I subtract 165 from both sides, z is 15 degrees. So I'll write that in there. Now, that is an exact answer. There's no reason I couldn't use that 15 degrees for finding the rest of them, but I'm going to not do that. I'm going to use the number that is given to me, just on the off chance I made a subtraction mistake. So I'm using the 75 now. I'm going to label my sides: opposite, adjacent, hypotenuse. Now I have to figure out, do I want to find x or y first? Let's go ahead and find x. So I know the opposite, and I want to find the hypotenuse. So that means I'm using sine. Sine of 75 equals the opposite, which is 5, over the hypotenuse of x. I'll write out my proportion, cross multiply. So I have x times the sine of 75 equals 5. And I'll divide by the sine of 75. I'm just undoing that. And then this is the part I'll type that into my calculator. 5 divided by the sine of 75. And calculator says 5.2. So I'll put that there. That makes sense. It is longer than my opposite side by just a little bit. So it's good that the hypotenuse is the longest side. Now, when I go to find my adjacent side, I'm just not going to use that 5.2. I don't want to use that rounded value. So I'm still going to use the opposite and the adjacent. So I know I'm going to use tangent. I'm still using the 75. Just keep the same angle. There's no reason to switch to that 15 at all, because that messes up your opposite and adjacent sides. So opposite is 5. Adjacent is y. I'll go ahead and turn that into a proportion and cross multiply. So y times tangent of 75 equals, 5 times 1 is 5. And then I can divide by the tangent of 75. cancel that out, and I'll go type that into my calculator. 5 divided by the tangent of 75. And that says it is 1.3. So I get 1.3 there. And this would be just a good time. Double check that that all makes sense, right? Do my angles add up to 180? Is the hypotenuse my longest side? Is the angle across from the side across from the smallest angle the smallest side? All of those things can help you catch mistakes that you might have made along the way instead of having to get answers wrong that you could have figured out were wrong from the beginning. If it doesn't make sense in the picture as a whole, it's probably not right.